Now, the impulse momentum theorem. Impulse of a force is equal to the change of momentum. Integrations t1 t2 f vector dt is equal to del p vector. Force time graph area given change in momentum. Collision of bodies. The event or the process in which two bodies either coming in contact with each other or due to mutual interactions or distance apart affect each other motions. Velocity, momentum, energy or directions of motions is defined as a collision. In collision, the particles come closer before collision, and after collision they either stick together or move away from each other. Particles need not come in contact with each other for a collision. Law of conservation of linear momentum is necessarily applicable in a collision, whereas the law of conservation of mechanical energy is not. Types of collision on the basis of directions: one-dimensional collision or head-on collision, two-dimensional collision or oblique collision. The collision in which the particles move along the same straight line before and after the collision is defined as dimensional collision. The collision in which the particles move along the same plane at different angles before and after collision is defined as the oblique collision. On the basis of kinetic energy, elastic collision. A collision is said to be elastic if the total kinetic energy before and after collision remains the same. A inelastic collision. A collision is said to be inelastic if the total kinetic energy does not remain constant. Perfectly inelastic collision. The collision in which particles have no tendency to regain its shape is called a perfectly inelastic collision. In this collision, velocity of particle along the line of collision becomes equal after collision. Important points. Sum of mass moments about center of mass is 0. A quick collision between two bodies is more violent than slow collision, even when initial and final velocities are equal, because the rate of change of momentum determines that impulsive force, small or large. Heavy water is used as the moderator in nuclear reactors. as energy transfer is maximum if m1 is equal to m2. Impulse momentum theorem is equivalent to Newton's second law of motion for a system, on conservation of linear momentum is equivalent to Newton's third law of motion. Coefficient of restitutions Newton's law. E is equal to minus velocity of separations along line of impact upon velocity of approach along line of impact is equal to v2 minus v1 upon u1 minus u2. Value of E is 1 for elastic collision, 0 for perfectly inelastic collision, and 0 is smaller than E and E is smaller than 1. E is smaller than 1 for inelastic collision. Head-on collision. Head-on elastic collision. Linear momentum is conserved. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Kinetic energy is not conserved, but initial kinetic energy is equal to final kinetic energy 1 upon 2 m1 u1 square plus m2 1 upon 2 m2 u2 square is equal to 1 upon 2 m1 v1 square plus 1 upon 2 m2 v2 square. Ratio of separations is equal to rate of approach. E is equal to 1. u1 minus u2 is equal to v2 minus v1. Head-on inelastic collision of two particles. Let the coefficient of restitutions for collision is E. Momentum is conserved. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Kinetic energy not conserved. According to Newton's law, E is equal to v2 minus v1 upon e1 minus u2. By solving 1 and 2, v1 is equal to in bracket m1 minus em2 upon m1 plus m2 e1 plus in bracket 1 plus e m2 upon m1 plus m2 u2 is equal to m1 e1 plus m2 u2 minus m2 e in bracket e1 minus u2 upon m1 plus m2 v2 m2 minus e m1 upon m1 plus m2 u2 plus in bracket 1 plus e m1 upon m1 plus m2 is equal to m1 u1 plus m2 u2 minus m1 e u2 minus u1 bracket 1 upon m1 plus m2. Elastic collision. E is equal to 1 if two bodies are of equal masses. m1 is equal to m2 is equal to m. v1 is equal to u2 and v2 is equal to u1. If two bodies of equal masses undergo elastic collision in one dimension, then after the collision the body will exchange their velocity. If the mass of a body is negligible as compared to other, if m1 very greater than m2 and u2 is equal to 0, then v1 is equal to e1, v2 is equal to 2e1. When a heavy body collides against a light body b at rest, The body A should keep on moving with same velocity, and the body B will move velocity double that of A. If m2 get very greater than m1 and u2 is equal to 0, then v2 is equal to 0, v1 is equal to minus u1. When light body A collides against a heavy body B at rest, the body A should start moving with same speed, just in opposite direction, while the body B should practically remains at rest. Less in kinetic energy in elastic collision. Del K is equal to m1 m2 upon 2 in bracket m1 plus m2 into in bracket 1 minus e square in bracket e1 minus u2 square. Rocket propulsion thrust force on the rocket is equal to Vr in bracket minus dm upon dt. Velocity of rocket at any instant v is equal to u minus gt plus Vr ln in bracket m naught upon m naught upon m.